So in this discussion, we are going to interact on the concept of importance of Laplace transform in solving periodic functions. So first of all, what do you mean by a periodic function? What do you mean by a periodic function? So periodic function repeats itself in certain period. Am I right? It repeats itself in certain period. We know, very well known things are sine, cos or periodic functions, trigonometric functions. We have sine function is there, cos function is there, which are periodic in nature. For example, so if you take the sine function, so f of t equal to sin t, f of t is equal to sin t. Am I right? So it is a periodic function. Am I right? It is a periodic function. The reason is after certain interval, if you take piecewise, it is continuous. Okay, and also it repeats itself in certain point. So also we can say f of t plus 2 pi is equal to f of t. Am I right? Sine of 2 pi plus theta. Sine of 2 pi plus theta is again sin theta. Cos of 2 pi plus theta is again cos theta. Am I right? So periodic functions can be evaluated using Laplace transform. So already we have seen same kind of thing in Fourier transform also. Even Fourier transform works on this. But there is certain restrictions in Laplace compared to Fourier transform. Okay. So here Laplace transform works on piecewise continuous functions. Okay. Fine. So what is the formula involved? It's the same formula for everything in Laplace transform. So when we talk about periodic function, Laplace formula goes like this. Laplace of f of t is equal to 1 by 1 minus e power minus ps integral 0 to p e power minus st f of t dt. Okay. So we use this formula because here we take the periods. So here it is 0, 2 pi, 4 pi, it goes on like this. So 0 to 2 pi. So we work for that range because in that range it comes again to the same point, again it repeats. So here, suppose if I take f of t as a function, okay, it can be any function. For example, f of t equal to sin t for the interval 0 to 2 pi. You can work on this. Suppose we have f of t equal to t for the interval 0 to a and 2a minus t for the interval a to 2a. Even this can be a periodic function. So always don't think like periodic functions are always sine, cos, tan. Even algebraic functions. T is an algebraic function. It is a variable. So t, 2a minus t. Even this algebraic terms can be periodic in nature. Okay, can be periodic. Only thing is it has to satisfy the periodic condition. Only thing is it has to satisfy the periodic condition. Okay. So how is this range? So if you take the range, it starts from 0 to a again to 2e. So we can take this formula and we can expand this formula. Okay, we can expand this formula from 0 to a because p is nothing but here it is 2a. P is nothing but it is 2a. So you can expand the integral like Laplace of f of t is equal to 1 by 1 minus e power minus, in the place of p you will take the period. What is the period here? 0 to a to 2a. That's the final period. That's the ending period here. That's 2a. So 2a is integral 0 to, again it is p here. That is 2a. Then e power minus st f of t dt. Again this part you can split again. And you can solve or you can evaluate to get the required result. Okay.